In this project, we are going to practice some of the topics that we have seen in calculus and in math class. These topics include derivatives and limits. We will solve a problem based on the knowledge we acquired in these classes, but before we had to investigate some certain concepts that include rates of change, velocity, acceleration, equation for velocity, among others. To show how we made this problem, we will make a flowchart, procedure, and a final conclusion. So we're going to present problem number 2, which says, Julia had a very tough day and went on the roof of her 300-meter tall building to have some peaceful moments. Drinking a bottle of water on the top of the building was the best at the moment. After finishing the water, a very strong wind started and thrown upward the plastic after the bottle with an estimated velocity of 100 meters per second. Then they asked us for 6 different things, which we're going to present after this.
For letter A, we know that to get the position is the same formula as displacement, so we know which formula to use. We know that we have the following values. H equals 300 meters, initial velocity is equals 100 meters per second. Time is a variable, and we know that acceleration is always minus 9.81 meters per second squared. So now we just have to replace them in the formula.
So now, in letter B, we need to find the equation of the velocity for the plastic water bottle. The formula that we have is the limit when x approaches 0. We have to substitute the values. In number 2, we have to solve the signs and multiply the numbers in the outside with the numbers in the inside, and then just solve the binomial to the square, and we have the third one. Then observe number 4, and we search for a common factor, which is h, and we simplify. So then we substitute the value h to 0, because it's a limit, and then we got our final answer, which is v equals negative 9.8 plus 100.
In letter C, we have to calculate the acceleration equation for the plastic water bottle, so we are going to use the formula shown in the first bullet point. Then we substitute the values and we solve the operation, then we cancel the ones that can be cancelled, and finally we get the answer, that is negative 9.8 meters per second squared. For letter D, we have to explain the graph line, in which the first derivative is represented in red color and represents the displacement. The second is in blue and represents how the function looks. And the third derivative is acceleration, which represents acceleration. For the letter E, we use the formula we got on letter A, and we just substitute the time into 2 seconds, because the problem says that we have to calculate the height of the bottle after 2 seconds. With this, we got that the height is equals to 408.4.
So now, in letter F, first we have the equation to search for time. We have the formula for displacement over y, that is going to be y equals 300 meters plus 100t plus negative 9.8 times time squared divided by 2. Then we started solving the equation, and we organized it from the biggest exponent to the smaller one, which was y equals negative 4.9 t squared plus 100t plus 300. To solve it, we will use the general equation, and we just substitute because the first one is a, the next one b, and then c, and we just solve them. We have 2 answers because we always get one positive and one negative when using the general equation. So our final answer is t equals 23.06 seconds.
With this project, we learned that physics and calculus can be related to each other. For the problem we solved, we first investigated about derivatives, functions, and we applied them in functions such as acceleration, position, and velocity. The derivatives can also be applied in other type of physics problems, and we learned also that these formulas can be applied in real life situations.